Next we're going to talk about compositing renders from a CG package such as Modo or Maya or 3D Studio Max. And generally when we render out these images from these 3D packages, if we're smart about it, we're rendering them as multi-pass renders. And multi-pass renders simply refer to the fact that different elements of the image are broken up into their own files, and then within those files, elements might be broken up into their own channels. Remember that Nuke is capable of working with up to 1023 channels, so we can fit a ton of information inside each one of these files. So let's take a look at an example of a composite of a CG shot, a fully CG shot. Here we have two spaceships dueling in outer space as they head towards the moon. We have the protagonist's spaceship here named Connie Radar, and then we have an Apollo rocket capsule, and you can see that they are exchanging gunfire. So we have a lot going on in this shot. The elements came from Maya, specifically the Connie Radar rocket ship and the Apollo rocket ship, and then all of the thrusters that are coming out the back of them, all the particle effects work that was done. There's actually a star map back here, and also obviously the moon. These are actually being animated and done inside of Nuke. So let's take a look at the script that was used to create this. I'm going to go ahead and hit the F key over my node graph, and you can see the entire node script necessary to bring these elements together. Now, this is much larger than any other node script we've dealt with so far, and really it's actually a simplified view of what this node graph might ultimately be. Once again, the power of this is that each element is isolated and can be manipulated with additional nodes by itself. So we might end up adding a couple of dozen nodes to each of the elements to get the look exactly right. And the benefit to this, once again, is twofold. First of all, we're going to be able to make fine adjustments here in the composite, and the Nuke is going to be much faster at making these adjustments to blur and color and the appearance of these elements than it would be to render them again a second time out of, in this case, out of Maya. The render time out of Maya for something like this, which is utilizing global illumination and ray tracing, it would definitely be a slow render just to make a small tweak. So here we have the advantage of speed. And then the other advantage is when we have a series of shots in a film, the shots will have similar elements and might even be composed in similar ways, and it becomes really helpful to set up an automated pipeline using Nuke to combine these elements. So for example, over the course of a movie, if the shade of one of the characters' colors, or for example the color of Connie Radar's spaceship has to change over the course of the entire movie, we could actually go into the composites and automate a process where we update a grade node connected to just that element across all of the Nuke scripts, and once again render them out much faster than it would require to render out from a full package. So let's start looking at how many elements we have here. So I'm going to start at the top, and this is our background. It's the moon and stars, and here you can see we have a star map, which is actually a very large image, over 16,000 pixels across, and this just allows us to get a very detailed view of the different constellations. This is an accurate star map to using NASA data. So obviously we don't need that much space, so we're going to go in and crop it. We have to shuffle around some of the channels because right now all of the information about these white star points is only in the red channel. So we use the shuffle node to move that across all of the red, green, and blue and alpha channels. And then we are going ahead and creating a camera move for this shot by using a tracker hooked up to a transform node. And the tracker simply tracked one corner of the spaceship, and that way we have our stars moving in a similar fashion to our spaceships. We have a very similar setup for the moon. Once again, the moon does not look like a moon right off the bat. That's because it's a black and white image, and it's only really contained within the red channel. You can see in the green and the blue channel, we have, well, in the green channel we have an alpha actually, and in the blue channel we have no information. So once again, the first thing we have to do is shuffle information so that that first image is across all channels. And actually, we'll put the alpha that was in the green channel into the alpha. Then we're doing things like adding glow, and once again adding that camera motion, and then finally formatting it for our frame, and then connecting it with our star background. So that composes the back of our shot. Next, we're going to add in the Apollo rocket. And the Apollo rocket is made up of two elements. It's made up of the Apollo rocket itself and some bullet holes that are being shot into it from Connie Radar's attack. And then we have the thruster itself. So we have the combustion inside the combustion chamber, and then we have the smoke trails and the different fire elements. So all of those combined together and then combined with the rocket ship gives us the Apollo ship. So you can really start to see how separating out these elements, it's relatively easy to combine them, but it is really given us a lot of control once we're ready to start adjusting things. Moving on, we have Connie Radar ship, and once again we have the different thruster elements combined together with the rocket ship and with the rest of the shot. And then the last piece is we have some tracer bullets, a little harder to see, so we're actually using a grade node to boost the appearance of those and then merging the rest of the shot. So here's our final shot, and there's a this is a very good starting point. There's a couple of things that we might be interested in doing. For example, I used the example earlier of maybe we want to change a color of an individual element. Well, with a multipass render where we have the different elements of the shot as their own image sequences, that's relatively easy. We know that, for example, Connie Radar is a separate element here that can be turned on and off. And so all we have to do then is add a grade node. Actually, yeah, we'll add a grade node, and we'll go ahead and use the multiply command, and we'll open up the individual color channels so we can make adjustments here individually. So here maybe we want to well, these color adjustments wouldn't necessarily make sense. Let's go ahead and do a color adjustment that makes a little more sense. Let's go ahead and do a hue correct. So we're going to go use the hue correct, and what we're going to do is go into the red channel. We're actually going to see where that is, right about there. We're going to use that to desaturate our red. Sorry, wrong channel. Go into the red suppression, and we'll go into that part of the image, and we'll go ahead and drag that down until we have near black and white. And then maybe we want to take the blue channel, which creates these lines here, over here on the violet end of the spectrum, and maybe we want to boost the appearance of their color. Or we might do the exact opposite. We might bring the red way up and reduce the blue outlines down to gray. So we have a lot of control over the individual elements, and it's really powerful to make those kinds of adjustments with a multipass composite. If we didn't have these separated out as separate elements, in order to do the same thing, I would have to mask out just this element from, at the very least, from the background. But even if the Apollo ship and the Connie's ship were on the same render, I would have to at least do a garbage matte for the Apollo ship so that those color adjustments don't affect it as well. So keeping them separate really helps us out here. There's a couple of other ways that this is useful though. What may not be visible right off the bat is that there is additional channel information available within these renders as well. So we so far have talked about the 3 standard color channels of red, green, and blue, and alpha. And I can view those with the hotkeys inside of my viewer. But there are additional channels that our 3D packages are capable of generating, and we can use them for all sorts of things. And that is the other biggest benefit of the multipass render, or in this case, multi-channel render. Now each one of these elements has their own channel information, but I'm going to specifically be talking about the Apollo capsule and Connie ship. So let's start with Connie ship. As an example here, one thing you might notice about the shot is that as the ships are moving around, they're getting jostled around pretty good, but there's really not much as far as blur on these ships. They look like they were shot with a camera that might have had a small shutter, or for one reason or another, it looks CG actually. It's one of the problems. We need to soften this up a bit. We need to add some of the artifacts that would come with shooting this scene with an actual camera, although obviously it was computer generated. So one of the simplest ways to do that in this shot is to add motion blur. Now we could render motion blur out of our 3D package, but motion blur has a tremendous effect on render time inside of a 3D package. In order to get realistic motion blur from a 3D package, you might end up with a render time 10 times the normal unblurred frame. However, we can use the channel data that our 3D package is outputting to do a blur inside of Nuke, and it'll be much faster, almost instantaneous. So I'm going to start accessing one of our first channels, and for now I'm just going to look at Connie's ship by itself. And let's go ahead and go up and into the top left of our viewer where we have our channels drop down. And we see RGB and RGBA and alpha, but we also have a couple of additional channels which we haven't seen before. We have one here called GI, one called Reflect, one called Specular, and one called Velocity. Now I can select these different channels and see what they look like. At first, at least with Connie ship, it won't appear too obvious what they are. For example, GI just looks like very faint colors, very dark. Reflect looks like some cast light on the edge of where the ship was. Specular, once again, looks like highlights. And then Velocity probably looks oddest of all. It looks like an alpha channel, but in this case it's colored yellow. And then later in the shot it's actually green. Now, Velocity is what we're going to be using first. And this really goes to show how you can use some of the more unique channels coming out of CG renders to do interesting things inside of Nuke. The Velocity channel in this case is actually a UV motion pass. And UVs are simply a way of defining motion in 3D space, or position in 3D space. So a motion UV pass would define the motion of each individual pixel with a color. This is done by combining different color channels. In this case, our U and V channels are stored in red and green channels. You can see we have nothing in blue and nothing in alpha. And when they are combined, they create a map that we can use to determine which direction each one of these pixels was headed within the CG animated scene. So it all sounds kind of strange, but what we're doing once again is we're using this map to create motion blur. So the tool that I'm going to use to create that is called Vector Blur. So I'm going to select the read node and use my tab search to look for a vector blur. And you can see we'll get to this later, but if we actually don't have this UV pass from our 3D render, we can actually generate motion vectors, but that's for another time. So let's do a motion blur. And we'll go ahead and switch this view back to RGBA so we can see what effect we're having on the full color image. So this is the vector blur node in the properties bin. First thing it's asking us is which channels do we want to affect. We want to affect all channels. And then it's asking us for which one of our channels is called a UV channel. Because once again, a channel inside of, in this case, an EXR file can be named anything. They're arbitrarily named. So even if it was named UV channel, Nuke wouldn't necessarily know that that is what your UV channel should be. But in our case, it's not even called UV channel, it's called velocity. So we're going to select the velocity channel, and instantly we see some results. We see that the ship is starting to blur in the direction that it's headed, which is based on the streaking towards the upper right side of the screen. That's wonderful. We're getting some really nice motion blur here. Couple of problems though. We'll fix these. If we look at our alpha channel, we can see that we have some clipping issues. Maybe our settings aren't exactly right, but our motion blur should be smooth and should be extending out into the alpha. Right now it's really only blurring the area within the UV mask, which is looking fine, but motion blur extends out past the object and behind the object. So we need to change that. In order to do that, we're going to make sure that we have the vector blur for the alpha turned on. And once again, we're going to make sure we have the right channel selected. In this case, it is the RGBA alpha. And now we are ready to start seeing blurs inside of our alpha channel. And then the last thing we need to make sure we have set correctly, and this is dependent on our renders, is the method. In this case, we're going to change this to forward. And forward is going to just coincide with the type of motion vector pass that we have rendered out of our 3D package. And now we're finally starting to see some blurring outside of the alpha channel. Going back to the RGB view, see once again it's looking pretty nice. So finally we have a nicely blurred image. One last issue to fix here. We saw that when our blur extended outside the alpha, we started to get our image going outside of our original bounding box. And that's simply because Nuke cannot determine how much blur there's going to be, so it doesn't know to extend the bounding box by a certain amount. And it doesn't want to slow down the processing of the image too much. But the vector blur option does give you a slider for changing your bounding box size. So you can see right now, where the image is hitting the edge of the bounding box here and here, the pixels are simply being repeated to the edge of the image, as it should. So let's go ahead and grow that bounding box though until all those repeating elements go away. And in fact, we'll give it a little bit more because we don't know how much this image will blur. So now we're a safe distance, the bounding box is a safe distance away from any of our image data. Now we can look at this rendered into the rest of our scene, and we can see that's looking quite nice. So this is much better than a directional blur, which is another way that we could fake motion blur inside of a compositing package, because this is going to blur individual elements that might be going in different directions within the render. It's something that would be impossible to do with a directional blur. And this is also, as you can see, much faster than a CG render. It's really just taking as long as necessary to read in the frames. The vector blur does not add a lot of time to our composite render. So once again, that was all using a channel that we previously had talked about called a UV motion pass. Let's talk about some other channels though, and we'll use the Apollo spaceship as an example. So here's our Apollo spaceship. And we have, once again, the same kinds of channels. If we go to our channel dropdown, we have RGB and A, but we also have global GI. And I'll start talking about what these mean now. GI in this case stands for global illumination. So that is the lighting model that was used to illuminate these models inside of Maya. And here we can see the global illumination contribution by itself if we select GI in the dropdown. Similarly, we have any reflections that might be on the surface. If the surface is metallic or mirror-like, then it would have reflections. And here you can see where those reflective surfaces are on the edge of the metallic thrusters and the bell of the main thruster. And then we also have this kind of shiny material around the bottom of the thruster. Finally, we have a specular, and specular is simply that. This is all our light glints and highlights caused by point lights. So, as would be expected, we're seeing lots of highlights on the edges of things, especially metallic things. And we also have effector pass here as well. So we can see how the color changes based on the direction of the object. So one of the first things I'm going to do here is I'm going to once again add my motion vector setup, because the blur is important to have for this element as well. So I'll set all my settings again. Vector, forwards, and make sure that my alpha is set. I'll grow the bounding box just a bit. Not quite as much as Connie's ship, because the Apollo ship in this shot doesn't move as dramatically, so we don't have to worry about the motion blur extending out the bounding box. So that's one of the first things done, but the next thing I want to do is I want to start using some of those additional channels to really start tweaking this image and taking some of the plastic look of this space capsule out of here. So my RGBA, although it's not labeled as such, is actually a combination of a lot of these channels. If I really wanted to have a powerful way of modifying my look of my CG renders, RGBA would actually be what is known as a beauty pass or a diffuse pass. And the diffuse pass is really the model as it exists in the shot with only diffuse lighting contributions or ambient lighting contributions. So there would be no specular highlights, no reflections, no global illumination or ambient occlusion or any of the shadows and highlights that really make for realistic lighting. It would look like a completely flat object. Quite frankly, it would look weird. But that allows you to really make adjustments to the object separate from the highlights and the reflections. So it's a very powerful way of compositing. Here, I'm a little more limited in what I can do. I really can only affect things like reflection and specular. So I'll use specular as an example here. I'll increase the shininess or the specularity of this ship by modifying that. So one of the first things I have to do is I have to separate this channel out from the rest of the image from RGBA. Because if I just affect RGBA with a grade node, which I can do by adding one now, and I try to increase the amount of specularity, you can see I'm increasing the specularity, but I'm also increasing all the other channel information as well. So there's two ways I can do that. For some nodes, you have the ability to affect just individual channels, and the grade node has that ability. So anywhere where I see a channels drop-down, I'm going to be able to affect a channel without affecting others. So here I can change from RGB to specular, and now my sliders would only affect my specular. I have to actually look at it while I make those adjustments. And you can see the specular is being affected while the RGB image remains unaffected. Well, that's great. I can make adjustments to my RGBA, but I need to now fold those changes back in to the image. So there's a couple of things I can do for that. one of the simplest things is to use what is known as a shuffle node. Now, shuffle nodes we've used in the past for moving channel information into the alpha channel, which is really the only additional channel we've talked about. But really, you can use the shuffle node for shuffling around any channel information. So the more channels you have embedded in an OpenEXR file, the more useful the shuffle node becomes. So I'm going to go ahead and attach shuffle node to this grade node. And I'm going to say that my incoming from the grade node, I really only want to be using the specular. And the red, green, blue from the specular is going to be the red, green, blue going out. And I don't really need an alpha, so I'll go ahead and turn that off. Okay, so now, even though I'm in RGBA view, I can see my specular channel by itself. So that's great, but what I actually need to be doing is blending this newly changed specular view with the original Apollo rocket. So the final step here is to add a merge node. I'm going to merge A over B, so my specular over my original image. And then while that's happening, I'll make sure my viewer is connected to it. And now what I should see is when I adjust my grade node, I'm only affecting the specular highlights. So once again, this was I didn't use a keyer, I didn't have to use any rotoscoping, but I am able to make fine adjustments to just one part of the image by separating out channels with using the shuffle node. If we look at our file composited image, for example, as this rocket ship's flying along, we might want to add a expression to this gain on the flicker on the specular to make it look like we have some cast light from the rocket ship creating some flicker on the specular highlights. So a lot we can do with that. So that is an overview of channel information inside of Nuke. Very powerful. It does require the cooperation of a good 3D renderer, though. Most 3D renderers are going to be able to output simple channels such as the motion vector pass, other channels such as the Z-depth buffer, which is a standard buffer that 3D renderers will use. And that, once again, all it's doing is defining how deep into your scene the objects are. It's defining the third axis. We have X and Y, but we don't really have the depth of the object when we're dealing with the 2D composite. So all these channels can be very useful. We might see some more of them coming up in later chapters, but for now this is a good overview. Next chapter we're going to be talking about keying. Keying is the process of automating a lot of these separations of foregrounds and backgrounds. So stay tuned for that.